Hey kids, this is our Polynomials Test Review answer video. I have my Amazon Prime music in the background called Classical Focus. A lot of just moderately well-known, if you know classical music, pieces. Nothing really specific about making you focus, but they say that Baroque music is supposed to help your brain cells focus, but who knows. Alright, so let's get started. So we're factoring or simplifying all the way through here. So for the most part we are factoring, and notice it says factor completely. So make sure that you recognize that you want each factor, so that's each set of parentheses, not to have a GCF other than 1. Okay, so on this first one I see a 1x squared. That makes this easy for me. I'm looking for factors of C, which is 121, that add up to 22, which is B. Right here, so factors of C that add up to B. That happens to be a perfect square as well, so I also recognize that this is a perfect square trinomial. And there you go. And I would double check that by actually multiplying it out. And I would probably use distributive property or FOIL, but here we've got, let's see, x times x, x squared, x times 11, 11x, 11 times x, another 11x, so 22x, that gives me that, and 11 times 11 is 121. So that is my answer. So I had a couple kids ask, what, when you answer, when you give an answer and you're supposed to give it in factored form, what does that look like? Well, it's going to be either two binomial factors like this, or one binomial factor and an exponent, or let's look at this one. Well, 3, 21, and 24 are all divisible by 3, so let's take out a 3. So we're going to divide everything in here by 3, leaving y squared plus 7y minus 8. Okay, and so on other problems like this one, we have a numerical factor because everything was divisible by 3, so we had that GCF we could divide out. And because this is a factorable trinomial, we're looking for factors of -8 that add up to 7. That'll be +8 and -1. So in this answer, you've got the numerical factor and then two binomial factors like so. Okay, on the next problem, we've got a GCF again. This time we got a GCF of 5, so let's divide out the 5. Okay, and something that might have occurred to you is to look at it and think, oh, let's see, 2 terms, subtraction, hey, difference of squares, but 5 is not a perfect square, so probably that's the GCF to come out. And indeed it was, because a squared minus 4 is a difference of squares. So to factor a difference of squares, we find the square root of each term. The square root of a squared is a. And the square root of 4 is 2. And it's 1 plus and 1 minus to get that difference of squares pattern. So in that one, again, you've got your numerical factor and your two binomial factors. Now, I did not stop and multiply this back out or this one, but do notice that if you do that, you will get the original problem. And if you do that, remember that when you distribute this 5, you only distribute it to the first set of parentheses, then FOIL, or FOIL, then distribute the 5 to the answer you got from foiling. Use the 5 only once is what I'm saying here. Alright, on this problem we are distributing a -3. So I've got 4a squared plus 7ab minus 3b plus 9b squared minus 6ab, because it's -3 times 2ab, minus 15b squared. Put that underneath that one. And then plus 3a squared. I'm going to put that under that one. And so the only one that I have to look at combining here would be these two. Otherwise, I lined them up. All right, so we got 4a squared and 3a squared is 7a squared. Got 7a squared in my answer. Plus 7ab and then minus 6ab should come out to positive 1ab. Minus 3b has nothing going along with it. And then 9b squared minus 15b squared is minus 6b squared. So that's just sort of in there to get your polynomial skills back from the previous chapter, the previous unit. Okay, and to continue this pattern here, let's circle my answer. Okay, factor. All right, again, look for a GCF. So the first thing you're doing when you're looking at a polynomial that you have to factor is looking for a GCF. And everything's divisible here by 2, so we're going to factor out a 2. Okay, and again, I have a perfect square on the end, so could this be a perfect square trinomial? Yes, it is, because the square root of 100 is 10, and if you multiply x times 10 times 2, you get that middle term, and that's that pattern we learned. So sometimes your factored form will look like so, where it's a binomial factor twice, technically, because it's squared, and then a numerical factor. Again, just a simplified problem to get you remembering what we're doing here with these problems. So two distributive property expressions stuck together here. So negative 12x squared when I distribute the negative 3 plus 21x, and then plus 56x minus 14x squared. So now I've got to combine my like terms. 14 and 12 is 26, so negative 26x squared. 21 and 56 is 77, so 77x. All right. All right, more factoring. So this is a problem where I start off by looking at it and saying, hold on, something's wrong. I have an a cubed in there. I'm not used to seeing that. 8 to the 5th. Okay, I have a GCF. So what's the GCF? Well, in this situation, if I look at those numbers, we've got 3, 15, and 6. So 3, because 3 goes into both 15 and 6. And then a to the 3rd, because 3 is the smallest exponent I see up there. Now I could be that I divide this out and then I've got more I can factor. Let's find out. Well, 3a to the 5th divided by 3a squared is going to be, 3a cubed is going to leave me a squared minus 5a and then plus 2, because 6 divided by 3 would be 2, and then a cubed over a cubed. And that's it, folks, because look, there are no factors of 2 that add up to negative 5. They just don't exist. Okay, sorry, my dryer just buzzed. Okay, now over here, again, GCF, I see a 2, and I also see an x squared. So 2x squared. And what does that leave? Well, it leaves 4y squared plus 4y plus 1. Now, slow down a little bit, Ms. Lecomte. What did you just do? 8 divided by 2, is 4. And then if I take out the x squared, I'm left with the y squared. Here, 8 divided by 2, again, 4. Take out the x squared, I'm left with just y. And then if I take out this x squared, I'm left with just 1. Now, this is factorable. Now, I see a perfect square and a perfect square. But if I didn't, I could use my A, C, and B method. And that's what I'm going to do here as a good review. So AC is 4 times 1, or 4, and B is 4. So I am not worried about this 2x squared. That's just sitting out front. It does not affect the factoring I'm doing inside the parentheses. So I need factors of 4 that add up to 4. That's easy. That's 2 and 2. So 4y squared plus 2y plus another 2y plus 1. And now I look for the greatest common factor in the first pair, which is 2y, leaving 2y plus 1. Leave a space, write the same factor, 2y plus 1, and the only thing that could go in front of that is a plus 1. Okay, you with me so far? All right, so if 2y times the quantity 2y plus 1 times the quantity 2y plus 1, if that's what we've got, then we've got 2y plus 1 times the quantity 2y plus 1, so that's squared, and we had a 2x squared sitting out front, so that's a pretty complicated one there. Not too bad, though. All right, a difference of squares. I immediately can tell, because I'm looking at the numbers and I see a 25, which is a perfect square, and I see a y squared. So take the square root of each thing. Square root of 25 is 5. And yes, that still goes first. Just because it's a number doesn't change anything. Square root of y squared is y. That goes second. 1 plus, 1 minus. And it doesn't matter if I put, I could have put the minus first and the plus second. It doesn't matter. Okay, and yes, that's okay. Even though the variable comes second, that's still okay. All right, so this one is sort of an application problem. Find the perimeter and the area. So the first thing you want to remember about perimeter, forgot to switch colors. First thing you want to think about with perimeter is the fact that you want 2 of each side. So 2 of the 3x squared minus 8x, because it's this side and this side, and 2 of the 4x squared. So we're going to distribute and combine like terms. So this is going to give me 6x squared minus 16x plus 8x squared. And that's going to come out to be 14x squared minus 16x. So there's the perimeter. All right, what about the area? Well, the area would be the product of the two dimensions. So again, distributed property. This time we get 12x to the 4th minus 32x to the 3rd. And there's your area of the rectangle. Okay, continuing on. All right, I see two terms. I think difference of squares, and then I realize that 7, definitely not a perfect square, but 1 is. So this is 7, and then the square root of each one. Square root of x squared is x, square root of 1, square root of x squared, square root of 1, 1 plus, 1 minus. Difference of squares. Remember, when you multiply it out, you would distribute first, then FOIL, or FOIL, then distribute. Okay, on this next one, we've got yet another one with a GCF. Okay, so on this one, I see that everything is divisible by 6. So let's factor out a 6. Sorry, editing jump. I believe I was saying that I see a GCF again. I did not write the most comprehensive of reviews, but I'm going to address that in a minute. All right, so I saw that everything was divisible by 6 because it's 6, 24, and 24. And now I can tell factors of 4 that add up to negative 4 be negative 2 and negative 2. All right, so once again, I have a perfect square and then a factor out front. All right, number 13. Factors of, oh good, finally. Factors of AC, which is negative 18 that add up to 11. Factors of negative 18 add up to 11. Okay, negative 1 and 18. Or 1 and negative 18, nope. Negative 2 and 11, well, no, not negative 2 and 11, what am I saying? Negative 2 and 19, or 9, but that, you know, if they were the same sign, they could add up to 11, but they're not. 3 and 6, nope, that would be 3 or negative 3. Gosh, I guess that's it. I hate to say it, folks, but this one's prime. All right, that's all right. We've got a couple more here we get to do. So this is unique. We haven't seen this before. So here's what you're going to do with this. You're going to go ahead and factor the numerator. So yay, finally a good one for us to practice with. I'll do this one with the table method. So AC, just looking at the top. AC is negative 30 and B is 7. Factors of negative 30 add up to 7, 10, and negative 3. Okay, so I'm going to take this, draw my little table, put my 2y squared here, put my negative 15 here, put my 10x, and my negative 3x. GCF straight up, or not x, excuse me, y, and y, sorry. I'm kind of x-centered as a, I like using x as a variable. So GCF straight up each column, so that's going to be in this first one y, and in the second one 5. Straight across each row, and this one's going to be 2y. And on this one, because it's negative first, negative 3. Yes, negative 3. So we have, in the end, 2y minus 3 and y plus 5. All right, but it's over y plus 5. So what's going to happen here is that these two same factors cancel out. They divide off and cancel each other out. And 2y minus 3 is the simplified answer. And that's it for that one. All right, so that's new. That's different. I'm going to show you a shortcut for these when we get to 16 in a moment. Okay, moving on. Changing colors. So, just dividing. We're dividing straight down. So, let's do this one term at a time. Negative 27x to the 5th divided by negative 3x squared. Negative 27 divided by negative 3 is 9. X to the 5th over x squared is x cubed. Okay. Minus 9x cubed over minus 3x squared, so that's positive 3x. Plus 3x to the 4th over minus 3x squared is going to be minus x squared. And negative 15 over negative 3 is positive 5, and the x squared over the x squared cancels. Now that is not in standard form, so let's rewrite that. 9x cubed minus x squared plus 3x plus 5. That was nice. Simple. Just dividing. Okay, so let me show you a cool shortcut here. Based on what we're learning at this level, this is always going to divide evenly into this top guy right here. So you automatically know that when you get one of these problems, whatever you see in the denominator, that's one of these factors. You automatically know that. So that means that you can work backwards to find these. So you can just ask yourself, all right, well, if this is h, what times h do I have to use to do 3h squared? To get 3h squared, well, 3h. What times negative 2 would give me a negative 16? Well, positive 8. Let's double check and make sure that's right. 3h times h, 3h squared. Minus 6h plus 8h, positive 2. Yep. And then plus 8 times negative 2, negative 16. See that? See that? Not that hard. These cancel. There's your answer. Awesome. Almost done. Okay. All right. So I see a difference of squares, but I also see something with a greatest common factor of 4. So if you factor out the 4 first, you're going to get 4 times 4x squared minus 9y squared. And that is what we're factoring as a difference of squares. Otherwise, it would not have been factored completely. So square root of each one, one's a plus and the other is a minus. This is another one of these distribute and then combine like terms. I think because this is a place where we can all use just a little bit of extra practice. So distribute the minus 8x or negative 8x, we get negative 8x cubed plus 56x squared minus 32x minus 30x squared. I'm going to put that here. Get rid of this random minus sign. There we go. Minus 48x. And then plus 36. All right. Combine the like terms here. We get negative 8x cubed plus 26x squared, it looks like, minus 80x plus 36. All right. And then just a little bit more adding and subtracting. So multiply these polynomials. Here's, this is getting lengthy. So I'm going to pause it. I'm going to write this out, and then the answers are going to be coming right up. All right, guys, hold on. Okay, I'm back with number 19a and b. So we get, I used FOIL here, and I used distributive property down here. So first outer inner last, we got 16x cubed plus 14xy minus 40x squared y minus 35y squared. And there's nothing you can simplify on actually either one of these because the terms are all slightly different. All right, and then down here we end up with negative 12x to the fourth plus 20x squared y plus 12x cubed y minus 20xy squared. Whew. Okay, area and perimeter of this last one. Here they come. And finally, number 20. All right, the perimeter, you add all the sides together, combine the like terms. 2x plus 10y. The area is 1/2 times base times height. Now I used the commutative property to say, nah, I'll do 1/2 of this one because this one's even. So I did 1/2 of this, then FOILed them out, and 10x squared minus 9xy minus 7y squared. I am confident in you that you are prepared for this test. Come and see me if you need help. Email me with your questions. See you guys in class.